Hello and welcome to Prepspot. In this video, we are going to know about a fascinating and critically important topic that bridges environmental science, geophysics, and policy, the profound impact of India's massive groundwater extraction on the Earth's rotational axis. Over the next 10 to 15 minutes, we'll explore the origins of this issue, unpack the key scientific concepts and terminologies, examine the latest figures and technical details, and consider the broader implications for water security, climate, and sustainable development, not just in India, but across the globe. Whether you are preparing for competitive exams or simply passionate about understanding how human activities can influence planetary dynamics, this session will equip you with a comprehensive, memorable narrative and the essential facts you need. To begin, let's travel back to the 1960s when India embarked on the Green Revolution. Seeking to feed a rapidly growing population, the country embraced high-yield crop varieties and intensive irrigation practices. While this agricultural transformation dramatically increased food production, it also created an unprecedented demand for water, particularly groundwater. Fast forward to today, and India has emerged as the world's largest consumer of groundwater, pumping out roughly 250 cubic kilometers each year. To put that into perspective, this volume surpasses the combined annual groundwater use of all other nations. The majority of this extraction serves irrigation, supporting some 60% of India's farmland and 85% of its agricultural output, valued at nearly $200 billion annually. Yet beneath the fields of the fertile Indo-Gangetic Plain, aquifers have been drained at alarming rates, dropping by an average of 4 meters per year in the most affected regions. This relentless depletion has triggered another phenomenon, land subsidence, where the ground sinks as its subterranean support is removed. Now, you might wonder how draining water from underground reservoirs could possibly tilt the Earth itself. The answer lies in mass redistribution. Imagine the planet as a spinning top. When more mass shifts from one area to another, whether through melting ice in the polar regions or, in this case, pumping water out of the ground, the axis around which that top spins can be nudged. Scientists refer to this wobble as polar motion, and the line connecting the north and south poles, the Earth's rotational axis, has indeed shifted over time. Since 1993, the axis has moved approximately 80 centimeters, or 31.5 inches. Remarkably, recent research indicates that India's groundwater extraction accounts for roughly 15 to 20% of that shift, translating to about 12 to 16 centimeters of movement. These findings were published on 15 April 2025 in the journal Geophysical Research Letters by an international team led by Dr. Kivyon SEO of UCLA and Dr. V.M. Tiwari of IIT Delhi, who utilized data from NASA's GRACE satellites to detect subtle changes in Earth's gravity field and correlate them with water mass loss beneath India's plains. At this point, it's crucial to clarify our technical toolkit. The GRACE mission, Gravity Recovery and Climate Experiment, comprises twin satellites that orbit Earth in tandem, measuring minute variations in gravitational pull. When groundwater is depleted, there is less mass below the surface, and the satellites detect a corresponding change in gravity. Complementing GRACE are GPS stations that precisely track polar motion, allowing geophysicists to quantify how much the axis shifts. These data feed into complex geophysical models which simulate how mass redistribution, whether due to human action or natural processes like glacial melt, influences Earth's rotation. While GRACE and GPS yield high-resolution, global insights, one limitation is the uneven distribution of monitoring stations on the ground, especially in rural areas where groundwater depletion is most pronounced. This data gap underscores the need for enhanced monitoring infrastructure as we refine our predictions of future axis shifts and their potential climate feedbacks. Beyond the realm of geophysics, the implications for water security in India are profound. With only 4% of the world's freshwater resources yet 16% of its population, India is already highly water-stressed. Today, 256 of the country's 700 districts are classified as overexploited, meaning groundwater withdrawal exceeds natural recharge. In states like Punjab, Haryana, Uttar Pradesh, and Bihar, the heart of the Indo-Gangetic Plain, farmers are sinking wells deeper and drilling new boreholes as water levels plunge. In parts of Rajasthan and Gujarat, regions historically accustomed to arid conditions, the situation has become an existential crisis. Even South India, once perceived as water-rich, now faces rapidly declining aquifers in Tamil Nadu and Karnataka. The depletion not only jeopardizes agricultural livelihoods but threatens urban water supplies, industrial operations, and ecological balance, heightening competition among stakeholders and fueling social tensions. Faced with these challenges, policymakers and scientists have called for urgent reforms. Sustainable practices such as rainwater harvesting, drip irrigation, and crop diversification can significantly reduce groundwater demand. The Central Groundwater Board, CGWB, has advocated for more stringent regulation, recommending the arrest of overexploitation through licensing, metering, and community-driven management of aquifers. Innovative approaches, like artificial recharge ponds and managed aquifer recharge using treated wastewater, offer promising avenues to replenish underground reserves. Yet scaling these solutions requires political will, financial resources, and public awareness. As Gajendra Singh Shekhawat, India's Minister of Jal Shakti, has emphasized, water must be treated as a shared heritage, jealously guarded, carefully managed, and equitably distributed. Internationally, the Indian case serves as a cautionary example. Similar mass extraction in California's Central Valley and China's North China Plain has produced comparable, albeit less pronounced, axis perturbations. It's important to situate this discussion within a wider historical and scientific context. The notion that human activities could alter planetary rotation was first suggested in a 2016 study published in Nature Climate Change, which explored how mass redistribution from melting ice caps and groundwater extraction could induce polar motion. That work, though pioneering, was limited by data resolution and the relative novelty of satellite gravity measurements. The 2025 study builds on these foundations, leveraging 2 additional decades of GRACE observations and more sophisticated hydrological models to isolate India's contribution with unprecedented accuracy. By comparing observational data with model simulations, researchers were able to attribute a measurable portion of the 80-centimeter shift to groundwater loss, cementing the link between anthropogenic water management and geophysical change. For students preparing for competitive exams such as UPSC, SSC, or state-level tests, the key takeaways include understanding the scientific link between groundwater extraction and axis shift, the scale of India's groundwater crisis, and the policy measures under consideration. You should be familiar with definitions, groundwater, aquifer depletion, land subsidence, polar motion, and the principal tools, namely GRACE satellites and GPS, that enable these discoveries. Memorize critical figures: 250 cubic kilometers of annual extraction, 80 centimeters of axis shift since 1993, India's 15 to 20% contribution, and the 256 overexploited districts. Recognize the timeline, from the Green Revolution of the 1960s through the 2016 Nature Climate Change paper and 15 April 2025 publication. Finally, be prepared to discuss sustainable solutions, from rainwater harvesting and drip irrigation to policy frameworks proposed by the CGWB and the Ministry of Jal Shakti. As we wrap up, let's reflect on the broader lessons. The Earth is not an isolated entity. Its dynamics are influenced by human decisions as much as by natural forces. When we extract water at scales measured in hundreds of cubic kilometers, we are, in effect, shifting our planet's mass and nudging its very axis. This revelation underscores the interconnectedness of environmental stewardship and planetary health. It reminds us that safeguarding water security is not merely a local or national priority. It is integral to maintaining the stability of the global climate system and the habitability of our blue planet. Answer this question in comments. The correct answer will be given heart and pinned. Lastly, we just want to let you know that we are a newly emerging online platform for competitive exams. Creating educational explainer videos like these requires a lot of effort, money, and time. If you like these videos and want us to excel and create videos in all categories of competitive exams, then you can consider supporting us with a one-time donation through the Ko-fi platform and also by becoming a member through Patreon. This will help us create more such informative educational videos in the competitive exams space. So, one last time, subscribe and share this channel with all your friends who are preparing for competitive exams. And also, follow us on social media platforms. The links are given in the About section of the channel and also in the video description. So, see you in the next video.